SF2. Science fiction, science fact.
A co-production of NASA, Lewis Research Center,
and the Communication Technology Laboratory,
and WKAR-TV
at Michigan State University.
I definitely believe that there is life on other planets.
A real alien would probably have more eyes than humans.
The universe is expanding. They know we're here. They're trying to get away as fast as they can.
I'd love to go to another planet if I had the chance.
I think there will be wandering vagabonds in space.
My favorite planet is Earth.
Well, I think Saturn would be a wonderful place to live.
I'm not sure where science fiction writers get their ideas.
Good evening. Welcome to SF2, Science Fiction, Science Fact. My name is G. Harry Stine. I'll be your host for this live initial communications experiment. I'll tell you more about this experiment later in the program. In the studio with me are John Stith, Dr. Charles Sheffield, Ben Bova, and Dr. Jesco von Puttkammer. Arthur C. Clarke is standing by in Sri Lanka, and all of us are science fiction authors. With us this evening also are 17 scientists and civilians at the South Pole. And we have some other unusual guests that are with us tonight. Approximately 74 people, and this number is growing by the minute, across the United States and around the world, are linked right now through their home computers through the International CompuServe Information Computer Network. And they'll be asking questions and they'll be making comments by computer. The production crew members you see will be sending their comments across the lower third of your screen, and about half the comments you'll see are being sent to CompuServe as the program is going on, and the other half were submitted earlier. Now, a conference moderator for the CompuServe network, Dick DeLoach, will make an opening remark, and then comments will continue to appear throughout the show. We also have 4 science fiction artists standing by live. Artist James Christiansen will be watching the show on television and drawing from KBYU TV in Utah, and artist Don Maitz, Barclay Shaw, and Michael Whelan are in Whelan's home in Connecticut. As we talk here, they will draw images which they'll then zap through to our studios using Colorado Video's freeze frame TV, and this sends a still frame image over the telephone lines. And the production crew will receive these images and show them on the screen along with other space and science fiction images as we talk. And last but not least, musician Mark Sullivan is prepared to add science fiction sounds and music to accompany the graphics on the screen. So, let's begin. Does science fiction affect science and technology, and vice versa? I happen to think that it does. I've done a book called Shuttle Down, which was a science fiction novel about an emergency landing of the shuttle on Easter Island this was written in 1980, and NASA did send a crew down to Easter Island later to check it out as a contingency landing site. I did a book called Space Doctor, which looked into the possibilities of doing surgery and practicing medicine in space. And I'm in contact now with the space medicine experts down at Johnson Space Center in Houston. So in this way, science fiction, I do believe, actually affects science and technology. Another one of our panel members tonight, Dr. Charles Sheffield, also writes this kind of science fiction. And Charles, how much formal scientific training do you feel is necessary for you to write a good science-oriented science fiction novel, or anyone to write a good science-oriented science fiction novel?
That's one of the questions that we get asked again and again. And one answer, which was given by the mathematician Littlewood when he was asked how much mathematics you had to read and know before you could do original mathematics, he said no amount is either necessary or sufficient. And that tends to be true of good science fiction. In my experience, the single biggest requirement to write good scientific science fiction is an interest in science and the scientific process. If you have that, you have half the battle. The formal training is interesting and nice to have to give yourself confidence, but it's not so important as the interest and the willingness to learn and read on your own.
Now, you've written a lot about space elevators and commercial exploitation of the outer planets, of the use of Kerr-Newman black holes for energy exploitation, and use of zero-point energy of vacuum itself as an energy source, and inertial drives. When do you think they'll happen? What are the pacing technology items in order to make this science fiction become science fact?
Well, the when is always the hardest question. I wrote about room temperature superconductors in 1977, but I didn't expect to see liquid nitrogen temperature superconductors in 1987 or 1986. I put them 100 years ahead of us now. In fact, Edward Teller said we've seen discoveries in the last 8 months that we didn't expect for 200 years. That's always the danger. What we do in science fiction, we extrapolate as best we can, but because we're humans, we extrapolate linearly. We cannot see the singularities along the timeline that will produce the radical changes. So I certainly believe that we will see all the things I've described in my stories, or ones at least as strange and interesting, and perhaps more so. Tying a particular time to them is very difficult. We can look at certain required technologies, and we can pick some of them out very easily. For many of the things we all write about, we must have easy access to space. We must have a strong continuing research and development program in this country and around the world for these to happen. Beyond that, if you say, when will we have commercial application of black holes, then it gets very tough, all right? You know, it's the old thing about how do you cook a hare? First catch your hare. How do you harness a black hole? First you get one that you can work with. So the when is very difficult, but the fact that there are things ahead of us at least as surprising as anything we've seen, that to me is indisputable. And I wouldn't think that if someone were to tell me that there will be a strikingly new technological discovery or scientific discovery in the next 50 years, I would not be surprised by that. I would be very surprised if someone were to say there will be no fundamentally new scientific discovery in 50 years.
In other words, basically, we science fiction writers, although we're considered to be far out, are really quite conservative then.
We tend to err toward conservatism because it's impossible to think around corners. And that's what you have to do to predict the next breakthrough. We have to be human too, I suppose, unfortunately.
Well, yes, that's true. Do we have Arthur Clarke on the line yet from Sri Lanka? He's not on the line. Well, it's 6 a.m. in the morning out there, so probably Arthur, like other good science fiction writers, probably hasn't gotten out of bed yet. Most of us do other things than write science fiction, unlike Arthur. Charles, I know that you write science fiction on the side. What do you do basically for a living to pay the rent?
I use things that come down from space, pictures of the Earth, and I apply them to crop forecasting and oil and gas exploration and environmental control. All the things which would have been considered unthinkable from space 40 years ago are the things we now do routinely. And I write science fiction because the things I do every day are no longer exciting in that sense. Of course, they are exciting, but romance and excitement are a function of the times. In 50 years, room temperature superconductors will be dull stuff, and you won't be able to get the kids to read about it because it's boring. But what I do today is technology that we've had available for 20 years.
Harry, that just was an interesting question here by our online audience asking Dr. Sheffield and us whether we read both science fact and science fiction in our professional lives.
I think the answer is that in order to write science fiction, you have to read as much science fact as possible. It's a Red Queen's race. You're continually reading. Charles, I know that you probably
I read everything from the back of cereal packets to scientific papers, and that's a compulsion that most people have, I suspect, to write science fiction. They tend to be autodidacts. They teach themselves things as opposed to going off and taking courses, and they read a lot. And if anybody wants to write science fiction, there's probably no better advice than read everything you can get your hands on, including cereal boxes. Right? Get some of your best ideas from cereal boxes.
Robert Heinlein once told me that he was a compulsive reader and that his wife would never dare send him out to the garbage can with the garbage wrapped in yesterday's newspaper, or she would find him sitting out there half an hour later with a pile of garbage on the ground and he's smoothing the wrinkles out of the newspaper reading it.
Yeah, news is better in California than where
That's true, yes,
are more
yes,
interesting.
yes. Is Arthur online yet? Arthur's not online yet. Okay.
There was another interesting question on the online here asking Dr. Sheffield whether he thinks that some of his technologies, like the room temperature superconductors, could make things like flying saucers possible one day.
I certainly believe that today, if we chose to do so, we could make something that looks very like a flying saucer. I don't think you need room temperature superconductors. You just need somebody who wants to make an object that's saucer-shaped and flies.
In fact, a research scientist that I worked with years ago set out to design a flying vehicle that would be propelled by electrical energy. And without any intention of building a flying saucer, what he designed eventually was an object that looks more or less like a saucer, puts out a blue glow, and interferes with radio signals as it flies around.
For this achievement, I assume he was fired, was he?
Well, this was all theoretical, you see, and he did it on his own time. But what he needed to make it real was very lightweight electrical equipment, and that's what superconductors will do.
Mm-hmm.
So maybe flying saucers will become real.
Do we have anybody here would like to take a guess at when we might have biochemical room temperature superconductors?
And what they would be good for?
Well, very fast computers, perhaps.
There was a question like
Yes.
that right now.
Well, let's just put it this way. We're close to understanding, I think, what the superconductors that are at 90 degrees Kelvin are doing, how they're structured, what's their atomic lattice look like. Once you have that thoroughly understood, you can start making strides to making biochemical or any other form. But give another few years before the lattice structure's tied down and the theoretical models are fully established, which they are not adequate at the moment, and then we can start looking to implementation in a whole number of ways, biochemical or otherwise.
Speaking of biology, and this of course leads to living creatures, what have you, and mainly people in space. And Ben, you've written a lot about people in space. I know we all have. What do you think? What do you think that living on the moon is likely to be like? Has it been forecast enough in science fiction that we can really get a feeling on it, or has the Apollo data that's come back given us a better look at what it might be like to live on the moon, for example, or colonize planets?
Yeah, I think we have a very good idea of what it might be like. In fact, you know, I've done a book called Welcome to Moonbase, which is essentially an employee's manual for people who will one day work on the moon.
That's a brand new book, isn't it?
It is. The way this game works is that I think science and science fiction go step by step. The Apollo program gave us enough information to begin to write very realistically about living on the moon. What the fiction writer does is then ask himself, how will this affect people? Suppose we have a team of 6 people or 12 people, whatever, living under the conditions that I now know exist on the surface of the moon. What will life be like for them? What will their emotional reactions be? What will their problems, human problems, be? So that fiction, science fiction, brings to the scientific fact the human equation, which the scientists really cannot do. Fiction writers deal with human problems. And this is why science fiction so often may not be predictive in a mathematical sense, but it does prepare the reader for examining the future and avoid some of the shocks that come along. Science fiction readers, for example, going back 4 or 5 decades, were not surprised at the advent of nuclear power, nor were they surprised at the Cold War, because we had all read in science fiction stories in the 1930s and 1940s that atomic bombs could be possible, and if nations had atomic bombs, it would result in political stalemate. the politicians, the so-called leaders of the world, who weren't familiar with science fiction, came upon this discovery. It was a great surprise to them. Science fiction people said, gee, I read that in 1938. So it does give you a preparation for the future. But the thing is that science fiction writers are not trying to predict what will happen so much as showing all the different possibilities. It's like looking at the future through a kaleidoscope. Now, one of those little slivers of brilliant glass is going to be the future that actually unfolds, but you don't know which one. So reading broadly in science fiction gives you many, many different views of possible futures.
Basically, science fiction today, then, with talking about colonizing the planets, do you believe that it's keeping our minds on a frontier, a new frontier that we may have lost here in the United States and, in fact, in the world?
Well, I think there's very much of a frontier mentality in the States. We look on space as a new frontier. When you say colonizing the planets, though, that's almost a pejorative term. I think colonizing is a terrible word to use. I don't think that we are going to see large-scale settlements of a planet like Mars or Venus or whatnot, because, frankly, we don't need them. We now have the technology to at least conceptualize building environments in space where there's nothing now, where it's empty space. We can build completely Earth-like environments. We don't have to pollute Mars. I think scientists will go to Mars and study the planet.
But one of the main things that we're doing when we write science fiction, the readership of science fiction generally is a young group, below the average of the age of this country. One of the things we are doing is we are preconditioning the minds of the next generation to certain possibilities. I'm on at this again. Last time we were on a program together, I told Ben that my objective was the seduction of youth, and I meant that in a very specific way. I want the young people to think about the world in a certain way. The things that I like and would like to see in the future, and I'm not trying to predict the future, I'm trying to create and invent the future. And that's a legitimate piece of the science fiction game.
A positive future vis-a-vis the downside Holocaust.
A positive future and a realistic future, not a future that's fantasy, not a future that proposes impossibilities, but a future which proposes things we know we should be able to do but can't quite do yet. And the next generation will have the technology to do that. We may not have it today, but I'm after the next generation. I want to get their minds when they're malleable and young and persuade them that these are desirable and doable. And if I can do that, that's my objective accomplished in the books I write.
We have a man that's online right now who is basically talking through something that he invented. The gentleman that invented the communication satellite is with us by telephone from Sri Lanka. And Arthur, are you there?
I think I'm here, but at 5:30 in the morning, I'm not quite sure.
I know it's indecent to ask a science fiction writer to get up at this hour of the morning, Arthur, but how are you?
I'm feeling fine, apart from a bit bleary.
Well, yes. You have seen your science fiction prognostications come to fruition and come true in the communication satellite. I know you've written many other things. We're surrounded here tonight in the studio, Arthur, that you can't see it, but we're surrounded by monolith-type decorations. They're not black. They've been painted gray. I don't know whether that means that things are getting better or not. Would you care to comment on your work in science fiction and how you think it might influence science and technology in the future?
Well, first of all, who's speaking?
This is Harry Stine.
Well, Harry, do you realize it's 35 years since we met at White Sands?
Yes, indeed, and I snuck you in, foreign national into White Sands, and we watched the launch of an Honest John rocket.
Yep, and Bob Heinlein had just delivered me to you. Well, I mean, it's almost impossible to believe that so much has happened in one lifetime, and or even half a lifetime, and science fiction has had a very important role to play with that. And incidentally, I'm right involved in this at the moment. This will interest Ben Bova. I have in front of me at the moment 1,000 copies of astounding science fiction on microfiche. And I'm roaming through them. I'm working on a book which I've called Astounding Days, pulling out the things that interest me, discussing how right the authors were, and often, of course, how wrong they were. It's been extremely great. It's been great fun.
That sounds marvelous. That's the book I want to read.
Well, Well, I'm hoping to finish it the next month anyway.
Good. We hope so too. We're always looking for new science fiction coming out of Arthur Clarke. You're a very, very predictive
writer. Well, if I may add another commercial, Odyssey 3 will be out in January.
Great. We'll look for them. We'll definitely look for them. What you too have written about space elevators. You've written about a number of other things. What does your view of the future, Arthur, seem to tell you about when such things will happen?
Well, of course, this is not a technical problem, and one's always up against factors which make it impossible to predict anything specifically, which is one reason why I never deal very much with the near future. I like to have a safe horizon about 100 years ahead, and so I can't be contradicted. And we've seen, tragically, in the last couple of years, how all the best laid plans of NASA and a lot of people can go astray.
That was...
and there can, of course, be unexpected developments, positive as well as negative. I would just like to say what I think could be done, and maybe should be done. I'm not in Jim Fletcher's seat, luckily, poor guy, but so I can just be completely irresponsible. But and I was probably going to annoy a lot of people, I would say forget the shuttle and get straight ahead on the aerospace plane.
Well, I think that's the direction we're going to go, certainly. We've had a question from one of the people that's on the CompuServe network here tonight as to when you believe that we might achieve a computer with the capabilities of HAL in 2001.
Yeah, that's it. Well, there again, I'm not in that field, sort of in
able to kill people.
Practical sense.
Yes.
But I would say I'm pretty sure it's going to be by 2101.
Oh my!
Too conservative.
Yes. Well, perhaps you're being. I hope you're being very conservative on that, Arthur. But you gave an answer I think that's very important. Is that?
Well, I think I may be pessimistic.
You gave an answer earlier that's very important, that a lot of the technology that we develop seems to be paced very strongly by politics and by our willingness to accept them and use these things in the proper way.
Exactly. I mean, of course, the classic example of that is the Apollo program, and there again, you had entirely political decisions to go ahead with a technological project. Literally a handful of men decided that, and that was something which, it was quite unreasonable to expect. And it may happen again, although it's not quite so likely.
Well, I know you made a very fascinating statement many years ago that magic is a technology that you don't understand. I probably have not quoted you exactly.
The phrase is any sufficiently advanced technology is indistinguishable from magic.
That's quite true. I'm sorry I misquoted you there, Arthur. What?
May I give a new law I recently concocted? Because you raised the subject of computers.
Yes.
I say that reading computer manuals without the hardware is as frustrating as reading sex manuals without the software.
A great comment, Arthur. Is that Arthur Clarke's fourth law?
Well, it's my 69th law.
Oh, okay.
Bad.
Arthur, before we go talk to a group of people at South Pole, is there anything that you might like?
You're not kidding?
We're not kidding. We're going to talk to people at South Pole after we talk to you.
And I believe, surprisingly, they're using a communication satellite, which is sort of sitting just below the horizon.
That's right. So we don't know whether you're going to stay on the net and listen to this or not, but the next thing we're going to do is go right over to the South Pole and talk to a group of 17 scientists down there. Arthur, it's been wonderful to talk to you again. We're all glad to hear that you're well and doing fine and having new books come out. Any final words?
Very nice to talk to you again. I'm afraid I won't be in the States anymore ever again, or possibly not even in England, but I'm feeling fine, and I am busier than ever. Even if anything happens to my undercarriage, my typing finger is going to be the last to go.
Well, wonderful. Well, we hope to be able to climb on board a hypersonic transport here in the next 15 years and come visit you.
And I hope I might see some of you on the Queen Elizabeth II at the eclipse next year, too, by the way.
Very good. Arthur, thanks very much, and we're going to go now live to the South Pole. Hello, South Pole. This is Michigan State University. Are you reading me?
Michigan State, this is South Pole. We're reading you loud and clear.
Fine. How's the weather down there tonight?
Oh, we're having a mild 40 below. For us, that's a heat wave, especially at this time of year, and the winds are fairly calm at about 10 knots.
We were just talking with Arthur Clarke, the man that conceived the idea of the communication satellite through which we are talking at the moment. Does communications really help alleviate the isolation that you must feel down there at the South Pole? Over.
Oh, absolutely. We get the regular news through the ATS satellite that we're speaking on now. We also have the use of ham radio operations, which we talk on daily, and get some more information. And we're also able to talk and make personal calls on Saturdays and Sundays to talk to people back in the United States.
Now, you're living down there in probably the closest of all of the facilities that we have to what a lunar base is likely to be like. Or Ben?
Or a Mars base.
Or even a Mars base. Do you at the South Pole feel that you're pioneering in this respect, and that there are many things that are being learned down there, the way you live, and the way you interact with one another, that are going to be very applicable to living in small, very isolated quarters in space? Over.
I think it would be the same as if some people dreamed about living on a deserted island without very much contact with outside sources. This would be quite similar. You have to find out more things about your fellow crew members that you never really thought you would ever find out. And so that is the closeness. You really can't get away and be by yourself very much. So after 1 year, it begins to work on people. And yes, we would be doing some research in psychological aspects.
Incidentally, for the viewers, we are not getting live video from the South Pole at this moment. We're only getting a videotape. Ben, would you have any questions you'd like to direct at any of the people down there at the South Pole, since you have just come out with a book on moon?
I'm living in a very enclosed place. What do you regard as the greatest problem of living in this tight, enclosed community?
Keeping the people interested and entertained. They have many jobs and projects to do throughout the long, isolated winter, but there's only so many VCR tapes that you can watch, so many hobbies that you can have, and eventually the constant similar surroundings, and of course the outside darkness. We have darkness for over 6 months. Begins to work on people in a very slow manner, and you don't really realize it until you're compared to people that come in. We'll be having people come in 10 days, and that, of course, these are the same people that left us 8 months ago, so they'll be able to visually and audibly see what changes we've gone through.
You're not located precisely on the pole, are you, down there?
We're about 200 yards from the actual geographic South Pole.
How many members of the 100 Club do you have down there at the moment?
It's actually called the 300 Club, which refers to going outside without any clothes on at minus 100 degrees Fahrenheit after being in a sauna of 200 degrees plus Fahrenheit.
And this is this is a recreation I'm proud that's quite unique then to the South Pole.
I can't think of too many other places that you could actually do that. To answer your original question, out of the 17 crew members, there are 16 members of that club.
16 members of that club. Okay, somebody just hasn't had the motivation to go out and do it again. Yet, I presume.
Yes, that's correct. It's a personal decision. It's not really as rigorous as one might think. The actual preheating of the body in the sauna is sufficient to sustain your body temperature for quite a while, so it's more psychological than anything else.
Very good. Do any of you here in the studio have any questions you'd like to direct at the people at the South Pole at the moment, which is something that was totally science fiction as recently as 30 years ago?
I have one question.
Yes, Charlie.
I've just been reading the description of Shackleton's last expedition, the Endurance, and at the time, boredom and personal relationships didn't seem to be at all a factor. As I hear it, things are safe enough now that boredom is becoming a problem, or at least being in the same company for a long period of time. Has that been a change that has been observed in the last 10 years? When did this change come about? When did the South Pole become sufficiently accessible that the big worry was not pure survival? Or is it still pure survival?
The answer to that is 1956 with the IGY. South Pole Station was built, and that was the first winter over crew. We just celebrated the 30th season of having winter overs. About 20 personnel per year, making about 500 or so people that have actually spent the winter here.
That's quite an achievement. I hope that some of you 30 years from now will be able to help us man a lunar base. I hope we get to a lunar base much sooner than 30 years. I know that Ben and I and Charlie and many of us here hope that we be able to do a lunar base much sooner than that. We applaud the work you're doing down there and the things that you're learning. We think it's going to be very, very applicable to the exploration of Mars. We've had a number of comments come over the CompuServe network tonight asking questions that having to do with the reality of this with the exploration of Mars and so forth. And thank you. You've answered your questions very much, and we're going to go on to our next segment now. Thanks very much for being with us.
You're very welcome. Thank you for the compliments. I personally volunteer for the first lunar base. I would imagine that it couldn't be any colder.
Good. Thank you, sir. You have a good one down there now.
Harry?
Yes, John.
I wanted to comment on one of the CompuServe comments earlier, but I hated to interrupt long-distance lines to Sri Lanka or the South Pole. One of the comments that I didn't catch the submitter's name talked about wanting less sadness in our visions of the future. And I'd have to say that I agree with that. I think we need, right now, we could use a few less nightmares and a few more dreams.
We're having a lot of things come over come over from CompuServe here. They're scrolling across our screen almost faster than we can read them here, trying to keep a lot of things going. We see some of them. Perhaps back there in the control room you might scroll them twice so that we get a chance to have a quicker look at them, or scroll them a little bit slower. Also on our panel tonight we have a gentleman who has done some science fiction, and he's working right now with NASA, and Dr. Jesco von Puttkammer. And Jesco, you have been a science advisor to Star Trek, Gene Roddenberry. In the earlier conversations we had prior to the show tonight, you didn't seem to think exactly the way some of us science fiction writers do, so I'd like to hear the devil's advocate side of this thing.
You're getting right to the core of the matter. Well, what I was referring to earlier was my concern that if audiences, if young people put too much emphasis or trust into science fiction, it may help to trivialize a little bit the real space program. I noticed that one of the questions, or two questions on the online, has asked the same thing earlier. Science fiction, particularly like the television type or the movie type science fiction, has not depicted the space program in a very realistic sense, with some exceptions, like Kubrick's 2001 maybe. And that may have led a lot of young people to assume that it's totally safe, and that it's child play, and that it's almost like a circus flying into space. And then when we had our horrible Challenger accident, of course everyone was totally surprised that something like that could actually happen when science fiction had never told them about it. So there is something here which I think we have to be careful that in predicting the future, or in painting pictures of future scenarios, one ought to be careful that there is self-fulfilling capability in there, and that there is an educational value to science fiction, which means that science fiction writers have a tremendous responsibility in what they communicate, in how they see the future, in how they communicate the future. But I want to go back.
Could I point out the contradiction between what John said and what you're saying? You're saying on the one hand that people are saying, why do we have so many dystopian visions in science fiction? You're saying we have a Pollyanna attitude in science fiction, that we're not pessimistic enough.
And they're both right.
They're both right. I think they are both right, but they're certainly two completely different attitudes. I think science fiction contains many, many things. It contains the most pessimistic futures and the most optimistic futures. And with any luck, the reader will read enough to see that there's not one future being presented. There are many possible ones.
Yes, we're looking at various different scenarios of the future. And I know, Jesco, there are a number of us that looked at the possibilities of disasters with the shuttle. Before this happened.
As I said, I'm outnumbered.
Yes, you are.
That doesn't change the fact that there is a sense of unfulfilled expectations out in science fiction land when they look at the real space program. That we at NASA get a lot of criticism from science fiction fans who just can't believe that you can't fly faster than the speed of light, and that you can build a matter transmitter. I mean, this is a disservice which science fiction also is doing. One ought to see the other side. But I'm all for science fiction. I've written it myself. I've paid my university studies writing science fiction novels, and I worked with Gene Roddenberry on Star Trek: The Motion Picture, because there is a link, a very strong link between science fiction and space travel. It has always been there. It's a historic fact which goes all the way back to the beginning of astronautics, even earlier than that.
Cyrano de Bergerac.
It used to be called cosmic voyages,
yes.
And it goes back to the 17th century, just after Galilei discovered the valleys and the mountains on the moon, and realized that there are worlds out there, and immediately people started talking about cosmic voyages. And throughout history, you can trace these touch points where science fiction and science fact actually met, where space travel was invigorated and was stimulated by science fiction, and vice versa. Science fiction writers again were stimulated by space travel. A good example, I think the best example really is Jules Verne, probably the greatest contributor to the birth of astronautics, because people like Tsiolkovsky and Hermann Oberth and von Braun, they were all stimulated originally by Jules Verne. Reading Jules Verne made the impossible seem less so, and so they started going for it. And then later on, Hermann Oberth worked with Fritz Lang on a movie, 1929, called Frau im Mond, Girl in the Moon, which invented the countdown. Fritz Lang in that movie invented actually the countdown.
I've got to agree with you there, Jesco, because I've had young people come up to me saying, "You promised us space!" And I have to tell them, we didn't promise you anything, you have to work to get it. We've got a segment here now. Robert Forward, a science fiction writer, was not able to be with us tonight. I guess he got trapped in Brighton in the hurricane. But we have a videotape on some of the material that Dr. Robert Forward is working on. So if we go to that videotape now, and let's see what Robert Forward has to say for us on videotape.
The third example where science fiction actually contributed to my science was in the development of my second book, The Flight of the Dragonfly. I decided the world I wanted to explore and explain to the readers, and where I wanted to put it, but that meant that I now had to get my human beings out to Barnard Star. Now, instead of using a warp drive or some other magic thing, I, again, trying to write as hard a science fiction story as possible, as accurate a science fiction story as possible, I began to think of completely different ways of getting to the stars. Now, back in the 50s and 60s, people knew that if you made a large sheet of plastic with aluminum on it, and you put it out in space, the sunlight bouncing off this sail would give it a push. Now, it wasn't very much of a push, but since there's no friction in gravity, it would, after a while, the sail would build up a considerable speed. One of the things that came out in the publicity releases at that time was that the laser light was brighter than the sun. And that phrase, coupled up with my reading about sun-pushed light sails, I immediately invented the laser-pushed light sail. Now, the basic idea behind this is to take a laser beam and use it to push a very lightweight sail like this out into space. Now, to do this, we start out with the sun, which is going to be our source of energy, and the sunlight is going to be used to power a powerful laser that's in orbit around the sun. The laser beam will go out through the solar system to a final lens. Now, this is a very special lens. It's called a Fresnel zone plate, and it consists of alternate layers of nothing, which weigh nothing, and a very thin ring of plastic. This plastic is typically a micron thick, and when the laser light goes through that plastic, laser light that comes out is perfectly uniform and continues on as a beam for very long distances. If this thing is 1,000 kilometers or 600 miles across, and the laser is at a visible wavelength, then the focal length for this mirror, the distance at which the beam will stay without spreading, is 44 light years. That's 10 times further than the nearest star. So that means that all the laser light that goes through this lens will stay in a beam, all of it will hit the sail and continue to hit the sail all the way out to the target star. There is no light lost. We now put the light sail in the laser beam. The crew is a very tiny spot down here, and it too is 1,000 kilometers in size. This outer ring is 1,000 kilometers, the inner sail is 300 kilometers. The laser light will accelerate this thing up, this vehicle up, until it's going at 20 to 30, maybe 40% of the speed of light. It'll take a number of decades to get to the nearest stars, but as they arrive, the next question is how do you stop? You've got a laser beam coming from the Earth, and you think that all it could do is push. What we do is we bring out the central portion, turn the reflecting side around so it's facing the remainder part, which doesn't contain any crew or anything that's important. And now we have the laser light coming from the Earth through the lens and bouncing off this mirror. There's a big ring mirror. The laser light now bounces back the other way and is focused down on the smaller sail, which contains the crew. So this expendable part flies by Barnard Star or wherever you're trying to visit, and this part, being slowed down by the retro light, slows down and comes to a stop in the target star system, and then the crew can then use this sail as a light sail to explore the planets and explore the whole new star system.
I'd like to point out that we're seeing all of these comments from the CompuServe people on their online network from their home computers scrolling across the screen here, and we haven't referred to very many of them because it's sometimes difficult to follow that plus what's going on here, and a lot of the questions that are being asked, we're seeing them, folks. And sometimes we're just not able to respond to them as quickly as you might think. Another one of our guests here tonight, of course, is John Stith, and John has worked a lot of modern communications and computer technology into his science fiction novels, such as Memory Blank and Death Tolls. And I'd like to, I've got a couple of broad questions here for you, John. Does science fiction, do you believe that science fiction influences science fact, or the reverse? So that was a question that we started the program with. From the earlier conversations we had, I get the feeling from you that the answer is both, but how has science fiction influenced science and technology insofar as you're concerned?
I read a lot when I was young. I still read a lot, but I read even more then, and I read a lot of science fiction. And one of the things I got from science fiction was an optimistic attitude. I got the feeling that the scientific method meant you could take a problem and you could analyze it and you could find a solution. And I think that my science fiction reading has encouraged me to think that we're in an understandable world that has rules that can change if we apply efforts. And I think one of the other offshoots of my science fiction reading was that it pushed me toward a career in science. So, you know, that's one way it's going.
John, how for you is science and technology influencing your science fiction?
Okay. One of my very best instructors in high school was a physics instructor, and he tried to always teach any new concept with about 3 different techniques. So that his theory, I think, was that if you could see it 3 different ways, it could maximize your chance of learning, and it would let a wide variety of people learn that. And I think one of the things that science fiction can do is present science from a different perspective that would let someone else, you know, understand it more readily. In a book I finished recently called Redshift Rendezvous, I'm trying to make relativity accessible to a person on a real personal level. That the novel is set on board a ship in an unusual environment where slow light exists. Light travels at 10 meters per second. So you get some obvious initial conclusions, like you flip on a light switch in a dark room and you see the light slowly fill the room. All of your visual perceptions are out of date, even more out of date than they are in our environment. But you go past those and you get to real interesting things where if you run down a corridor, you see that corridor contract around you. People watching you run think your time is slowed down.
Fascinating concepts. Are you saying that you think we can find a place where this slow light might be found?
No. I think, thinking back to something Ben said earlier, that science fiction presents a broad spectrum of possibilities. I think in a lot of ways science fiction is like brainstorming. And this is one way of looking at science that I think would help someone else understand it. And I want to back up 1 minute. We've talked a lot about what science fiction does, but I think most of us would agree that it's got to be about people. It's got to be about characters we care about also, and that my ideal of science fiction blends both of those elements.
It's very interesting, the educational aspect, because when Hugo Gernsback started the first science fiction magazine back in 1927, one of his purposes was to help teach science to youngsters who never finished high school.
Ben, we've got a segment here on technology now. Let's have another look at this, at modern communication technology, the transmission of data by video bursts. Now, John Stith, would you describe on what we're about to see on videotape here?
Okay, we're going to see the result of a merger of a couple different areas of technology. The video is showing a video tracks board made by a company called Alpha Micro that's used to back up computer data to what's essentially a cheap fast tape recorder, a VCR. That same data, once it's recorded, can be sent out as a television signal, encoded in what looks like an unusual picture of black and white for ones and zeros at something like 80,000 bits per second.
Very fast.
Very fast. In writer's terms, that's 8,000 characters per second. This, I'm not kidding, this is even faster than Isaac Asimov can type. And it's the equivalent roughly of about 5 manuscript pages per second, or 25 rejection slips per second.
Hey, it's going out right now.
Yes, we're seeing it on the screen now. They've actually transmitted the actual burst, what looks like garbage on the screen.
Well, that was showing a demonstration of what it involves.
Are we ready now to do an actual transmission of an actual chapter?
I think they've got the tape ready to roll, and it's going to include an essay by Jesco von Puttkammer on reflections in a crystal ball.
Okay.
Which is roughly a 15-page essay transmitted in.
Okay, let's go directly now to this burst.
Just a few seconds.
In just a few seconds. This version, I think, is redundantly transmitted several copies so that there's allowance for tape dropouts or
this is it on the screen now?
Right.
Okay.
And this may last 10 or 15 seconds.
10 or 15 seconds, but they're transmitting a whole chapter, a whole article by Jesco von Puttkammer.
Can I make a plug for science fiction? I put this in a book called Sight of Proteus, except that I had the picture in color, with a color range from the ultraviolet to the far infrared, but just the same concept, which was the picture encoding of long information messages. So that was 1978. So that's relatively near in the past, right?
So we've already got, now we've got the technology, and we just have to apply it where do you see that other applications of this particular technology that we just saw would be?
The volume of information flow is only going to increase, and being able to transmit from one location to a variety of locations all at once to update the latest version of the Encyclopedia Britannica or whatever it is.
Or how about teleoperating remote vehicles?
Yeah.
Like the operators on Earth and the vehicles on Mars.
Okay, now, those of you watching may have noticed the results of survey questions that have come over CompuServe during the entire show here. Now, moderator Dick DeLoach has invited us to pick a question to ask the online audience at this time. And the question that those of us on the panel tonight are asking you is, how has science fiction, or no, it's a yes or no question, pardon me. Has science fiction helped you understand the modern world? An answer is yes or no. And we should see that coming up on the screen here as quickly as the CompuServe people get that. But in the meantime, let's review the results of the instant electronic surveys that have already been conducted during SF2 while these participants vote. Now, the questions that were posed, can we roll those on the screen? Do we have them? Here they come. They're coming up now. Okay. Here's the online survey results. Did reading science fiction influence your choice of schooling or careers? Yes, 68%. No, 32%. I don't think any of us here find that surprising at all, do we?
Not at all.
It sure affected mine.
Okay, affected all of us. Okay, the next one. How about the next survey question? Do you expect to travel in space during your lifetime? Well, do we have any data on that yet, or did it come in? Okay, apparently no. Yeah, there it is, 62%. No, 52% yes, and 48% no.
So it's 50-50.
That's kind of 50-50.
Yeah.
Okay, how about the third question? This is being fed. Would you be willing to join an interstellar space exploration mission that would last so long that you'd never again see those you knew and love on Earth?
Sure they would.
Sure they would.
Sure they would.
Now, I don't know whether some of us would say this is escapism or just trying to get away from problems.
How about if an expedition where you would never see those you hate on Earth?
Well, even more. Probably even more, yes. Ben, you always take an interesting alternate view. Number 4, can science fiction act as a valid forum for the exploration of ethical problems raised by new discoveries in science? Boy, that doesn't surprise any of us.
That should be a message to the science fiction authors.
That should be indeed. Indeed. Okay. Does that? Did we have a fourth? Here's the last one. Should we, United States, seek out opportunities for jointly funded space projects with the Soviet Union? Well, there seems to be a growing amount of international of desire for international cooperation in this area.
83 to 17.
83 to 17%. Well, judging from some of the things that that Viking showed on Mars, and some of the reasons to go back there, perhaps it's one of these things that we should and must do together. Now, are we ready for the results of our studio question? Have the CompuServe people upstairs, they haven't got the results? They're not in yet. Okay. I told you earlier that this was an experimental TV program. We've tried to meld together various communications technologies, home computers, TV, and this TV show, by the way, is going out via satellite, via Arthur Clarke's concept. We've talked tonight to Arthur Clarke in Sri Lanka. We've talked to the South Pole. Okay, the results came in on our survey here. Has science fiction helped you understand the modern world? And the numbers are 87% yes, 13% no. I think that's, again, a very, very strong statement.
As an example of how fast we change, I bet the studio audience was impatient for that vote result to come in.
I know I was.
Well, as I said, tonight this has been experimental. It's been experimental in more ways than one, because this has been an experiment In 1990s, NASA will launch the Advanced Communication Technology Satellite, in which we'll be able to do all of these things and more. They'll be able as many as 28 different programs of this sort, interactive, even more interactive than we were tonight. And I know, Jesco, you were upset about that.
That it wasn't really quite as interactive as it will be.
Yes.
And this was just a simulation.
Yes, this was a simulation, an experiment. Certainly like to thank John Bluth of NASA Lewis Flight Center and the Michigan State University Communications Technology Laboratory, particularly Dr. Carrie Heeter, and all of the students that donated their time and effort, in some cases their money, to make this program happen for you, for this experiment. And I hope that we have the opportunity, I know we will have the opportunity, as science fiction becomes science fact, that we'll see more and more of this sort of thing. We thank you for being with us tonight, and on behalf of our panel participants here, Dr. Charles Sheffield and John Stith, Dr. Jesco von Puttkammer, Ben Bova, and for myself, thanks for being with us.
I'm not sure where science fiction writers get their ideas. They might just think them up and write about them. I'm not sure.
I think science fiction makes fun of science, and it's good that they do.
Things that have been thought up in science fiction show up later in science fact. That doesn't mean they have to.
I hope we soon have shuttle service to the moon and beyond. I think that would be a lot of fun.
I'd sort of expected people to be living in space stations by now.
Well, I'd like to recolonize another planet with some other people.
There's a lot of stars out there.
There will be someday the new space desperados who just travel because it's there.
It's a big universe.
I'd like to have a couple clones and send them out into the world.
A robot 20 years from now would probably look very much like a human.
Better than a robot, I'd call it Spot. I probably wouldn't be able to be friends with an alien because sometimes I get scared of them.
I don't think there'll be anything like what they picture in the books. I mean, green men or anything like that.
They take you away and dissect you.
I think if the other life studied us before they came down, they might not be very interested in coming to make contact.
I see no reason to be so parochial to assume that human beings are the only intelligent life out there with an infinity of planets.
No, they won't take over the world. If they're intelligent, I don't think they'd take over the world.
Probably travel to other planets would be like going to different countries here.
There is as much creativity in science as there is in fiction or in art.
My spaceship would also would contain a whole city.
Oh, there's a lot of imagination that goes into science fiction. I don't know where these people come up with these ideas.
What will life be like?
Yes, I would like to travel to the moon. You know, the first chance I could get, I would go.
I'm from the planet Earth.
You close the pod door, Hal. Hal, close the pod door.